Okay, hello everyone. Okay, for the paper three, right? The first thing you go in, you need to check for me, the magnesium they're using which term, ribbon or strip? Because if they use ribbon, later all your answer must write magnesium ribbon. If they use strip, you use magnesium strip. Okay, so it depends on what you want. But then it will be a 2 cm. Then if unguided, you need to write the procedure. So the purpose of this experiment is to check the effect of temperature on affect the rate of reaction between magnesium and zinc. So what should you do? First thing, you need to clean the magnesium with sandpaper. Then pour in 50 cnq hydrochloric acid into the measuring cylinder. Then after that, use the measuring cylinder to measure. Then after that, pour into the beaker. Then heat the acid slowly until 30 Celsius and place on the beaker on the white towels. Now, putting it on the white towels is to make sure easier to see the magnesium dissolve. But remember, when you heat until 30 Celsius, right, this is what you do. You heat until about 29. Then you take your Bunsen burner away. Because thermometer needs some time to reflect the temperature. So if you take the Bunsen burner away, right, you will see the temperature slowly will increase to 30. So you don't heat until 30, then you turn off the fire. You will get about 31 to 32. So then if you use that to conduct the experiment, your graph will be a bit weird one. Okay. Then after that, after put on the white house, you insert the magnesium ribbon. Then start the stopwatch immediately. Stop the stopwatch once the magnesium ribbon dissolves completely into the hydrochloric acid. Then record the time taken for the magnesium to dissolve completely into the hydrochloric acid. Repeat step 1 to step 6 at the temperature of 40 and 50 Celsius. Okay, so this is your manipulated. Then after that, you have to record the results. So after recording result, okay, but for recording results, you have to depends on your stopwatch. So your stopwatch, right? If your stopwatch is analog, that is 1 decimal. If your stopwatch is digital, that is 2 decimal. Okay, you must remember this. Then this is you have to calculate this time. This is 1 over time. Okay, time and 1 over time. Then what is relationship? We can mention them. The higher the temperature of hydrochloric acid, the higher the rate of reaction. These two higher, higher. Okay. Then predict the time taken as soon as at 60 Celsius. So here you need to predict the time for 60 Celsius. You are not allowed to write because it's 50 ma. It should be less than 50 ma. You're not allowed to write less than 50. You must predict a value to me. Maybe you predict 15 second, 20 second, 25 second or so. Okay. Don't say less than 50. Okay, based on the marking scheme of paper 3, they don't accept this answer because you have this data enough for you to predict a number for me. Okay, then what is the observation? Highly recommend you to write colorless gas bubble release because for observation, right, they always follow inference. Inference, you have to explain what happened. So if you write magnesium dissolved into hydrochloric acid, right, you're very hard to write the inference. So the best you write colorless gas bubble release. Then after that, inference, you can say, what is a colorless gas? Means explain what is a colorless gas. So who is a colorless gas? Hydrogen gas is released. Then manipulated variables, you can write temperature of hydrochloric acid. Then after that, the time taken for magnesium ribbon or magnesium strip to dissolve completely in hydrochloric acid is the responding. Then the fixed variables will be volume and concentration of hydrochloric acid. Okay, please remember to check this. If magnesium strip is strip, it really depends on the question on the spot. Okay, it might give you magnesium solid. Okay, then after that, state the hypothesis of this experiment. So you can mention them. The higher the concentration of hydrochloric acid, the shorter the time taken for the magnesium ribbon to dissolve completely into the hydrochloric acid. This is 1 mark. Remember, ribbon and strip, don't forget. Then after that, operational definition is very simple. Operational definition, you need to write the observation. This is the observation. Then this is the simple procedure. Okay, so you see, same when a magnesium ribbon is added into a beaker which contains 50 cm hydrochloric acid, it depends on the question. If your one is 40 cm, you have to write 40 cm. Ribbon, if ribbon strip, you remember to change the question, change the answer. So if the experiment is repeated using magnesium powder, what will be the effect? Of course, the time taken will be shorter because magnesium is smaller size. So when smaller size, the total surface area will be higher. The surface area is higher. Okay, then predict observation if the magnesium ribbon is replaced by copper strip. Now, for this one, you see, based on the electrochemical series, the electrochemical series, kalau nak you can see copper is below hydrogen. So if you put copper into acid, there will be no reaction. There will be no reaction. So the reason is because it is less electropositive, so it won't able to react with acid. So based on your knowledge, take the relationship between the temperature, okay, and the rate of the food turn back. Of course, the higher the temperature, your food will spoil much more faster. So chemical equation will be magnesium plus hydrochloric acid, and then become magnesium chloride plus H2. Okay, then we put in this plus minus 2 plus minus. So we will cancel off. So Mg plus 2H plus will become Mg2 plus H2. Because Cl minus no change, so you can cancel it. Okay, so this is the one. So look at this. This is analog. So if your stopwatch is analog, you only take one decimal. So this is 55.0 second. This is 47.0 second. This is 41.0 second. And this is 37.0 second. Okay, this is the analog one. Okay, a digital one, I will show in this example. In guided experiment, they'll give you the procedure. Okay, so most probably will be guided. Then they will need you to draw graph. If guided, quite high chance they will ask you to draw graph. So for graph, right, you need to be careful on this one. This is y-axis, this is x-axis. So when they ask you to draw 1 over time against temperature, here is 1 over time. Then here is temperature. Okay. If the balik, they ask to draw a graph that temperature against time, 1 over time, then your graph will be temperature here, then 1 over time here. Okay. So I've draft a graph already. So this is the graph. Okay, for this graph, the scale, right, will depends on the spot, because if let's say 30 to 50, this graph is a bit too small. But because they might ask you to predict a value. Let's say if they want to predict 60 Celsius, then your graph need to adjust a bit. If the value predicted is within 30 to 50, you can adjust your graph to be 5 each. So your graph is somewhere here. Okay, it depends. Okay, it depends on the spot that what you need. The only special thing, you remember to write all the title, the title of graph, then the label, the x-axis, y-axis. Okay, everything must write 0, 0 here. Okay, the only thing special is for the KBSM syllabus, means before 2020, the syllabus that we learn 1 over time versus temperature is a straight line graph. But you can see you won't able to draw a straight line. If it depends on this point, it cannot. Like this cannot. Like this is totally out. At the middle here is like totally not touching any point. You are stuck here. Don't know what to do. So for this year, I think the K-bar part will be here. That you need to draw a curve graph. You ask me that, curve graph, the syllabus not what we call a straight line graph, man. It's a linear graph. So now I show you. Now, the example is given here. Textbook, the KSN syllabus, they have updated their syllabus to near to A level in Form 6, which is higher level. You see, this is what is mentioned in the textbook. page 221. For the reaction that occur at room temperature, each increase of 10 Celsius will increase the rate of reaction by 2 times. What does it mean? You see, using this theory, you weren't able to draw your graph to be 2 times 1, you see, to be straight line, you see. 30 Celsius is 2, 40 Celsius will be double, 2 become 4 here. 50 Celsius will be double up again, 4 will jump to 8. Then 60 Celsius will from 8 jump to 16. You can see how do you draw a straight line? You can see very obvious this if you do a straight line here, the other two is like totally off from the straight line graph. So the only method to draw is a curve. Okay, so this is the theory mentioned in page 221 of textbook. Now, if you go further, behind the textbook, there's a question to ask you to plot a graph. We can check from here. 1 over time against temperature. Look at the answer provided by textbook. Is a curve. Okay, you see real reaction versus temperature. It is a curve. But here it dropped down because about the enzyme denature or that. Okay, so after that we refer to there's one reference book. They have updated their theory according to the latest textbook. So this books, the reference book is EPH reference books. You can see here they got mentioned in detail about what is the effect of temperature on the real reaction. So here got mention. For many reaction, rate of reaction increase 2 times with every increase in 10 Celsius. And then they also updated their experiment graph. You can check here. The experiment graph here, 1 over time versus temperature is a curve. Okay. Some students will ask me, okay, there's another reason why the graph does not go, it's not a straight line. Because the temperature, our lowest temperature is not 0 Celsius. Because we have negative 10 Celsius, negative 20 Celsius. The lowest temperature is negative 273. So this graph, if a straight line graph, they need to slowly drop. The actual graph looks like this. Sorry. It is, of course, at negative temperature, the reaction still can occur, but of course, much more slower. Okay, so you also can see the Form 6 graph. So Form 60 is the Form 6 books. You can see it's a chemistry term 1 SPM. And then you can see temperature. This is the graph for temperature. For temperature, you can see it's a curve graph. It's a curve graph. You see, higher level, their answer is more accurate. And SPM, they also adjust the syllabus to the higher level. So you can see real reaction, temperature is a curve graph. Okay. Then here, same theory written in the Form 6 book that an increase of temperature double the real reaction. That's why I say this theory actually come from Form 6 and A level. They have a special formula to learn why the real reaction double. Okay. So this is the graph. Now after finish draw the graph already, right? They will ask you to take a reading. So this reading is like this. Okay, how do you write the relationship? So if the graph looks like this, what if the body of the graph? Okay, I got draw one sample for you also. You see, so this is the 1 over time versus temperature. Then if temperature versus 1 over time, the graph will look like this. You'll be a curve also, but curve this way. So technically, you can see that the graph, right? If 1 over time looks like this, if temperature over 1 over time will looks like this. Okay, the graph will look like this. So, but relationship, how do you write? You just write normal. The higher the temperature of hydrochloric acid, the higher the real reaction. Then after that, okay, they will ask you, after they draw a graph, they will need to give you 1 more marks that I want you to predict 45 Celsius is how many time. So then you have to refer back to the graph. 45 is here. Okay, this is the graph. 45 is here. You dot, then you see what is the value that you get. 0.0142. So 0.0142, then you come back to the question here. You need to show in the graph how do you get the 0.0142. Then after that, you divide and you'll get about 70.4. Then if they ask, okay, if they really ask you about why the shape, let's say they really come out very key, but why the shape is a curve, then you can explain the first safe answer. If you say write the normal theory first, the higher the temperature, the higher the rate of reaction. If they ask more than 1 mark, 2 marks, 3 marks, then you explain them. You write down whatever written in the textbook. For a reaction that occur at room temperature, each increase 10 Celsius will increase the rate of reaction by 2. Then if they re-ask for the third marks, then you need to explain a little bit on Form 6 theory, but I don't think it will come out lah. In the Form 6, we don't call that linear graph, the curve graph. They have the words called the rate of reaction increase exponentially with the increase of temperature. But normally, I don't think they'll ask until this detail. Okay. Then observation. Same observation, manipulated, follow back the first question. So the only difference, guided and unguided, is if guided, very high chance they'll ask you to write a draw graph. Okay, for hypothesis, same, you'll be the same, still remain the same. Then after that, okay, if they ask you now about compare the rate of reaction for 30 Celsius and 50 Celsius. So you can mention that 50 Celsius is higher. Reason you can write because the temperature higher, hydrogen gain kinetic energy and move faster. If they ask further about collision theory, but normally I don't think they'll ask because this is a paper 3, not a paper 2. So you can further explain, no? The hydrogen ion gain kinetic energy and move faster. More hydrogen ion achieve the activation energy. Frequency of collision increase, frequency of evacuation increase. Then if they ask you to predict the rate of reaction, if the hydrochloric acid replaced by ethanoic acid, the answer is it will be lower. Why lower? Because one is strong acid, one is weak acid. So weak acid produce lower concentrated hydrogen ion, so the rate of reaction will be lower. Operational definition, same just now. So they'll ask you why beaker need to place on the beaker, so you can explain now, so that the time taken for magnesium ribbon to dissolve completely in the water can be easily seen, because white color you can see clearly the magnesium dissolve. Okay, then why you need to clean the magnesium ribbon with sandpaper? You can write that because to remove the magnesium oxide layer. Remember magnesium ribbon and magnesium streak. Okay. Corrosion. So corrosion, displacement, all these they want you to arrange. So you can write like who is fast reaction, who is slow reaction. Then after that, this is the, if they really ask you about action to be taken to manipulate, you can write like, repeat the experiment by heating hydrochloric acid at 30 Celsius, 40 Celsius, 50 Celsius. Then how do you observe? It's okay, it's right now measure the time taken for magnesium ribbon to dissolve completely into hydrochloric acid using stopwatch. Remember magnesium ribbon and magnesium streak, we do look at the question what they give. Then after that, use the same volume and concentration of hydrochloric acid throughout the experiment. Okay, now so this is a digital watch. So for digital stopwatch, right? This one you just follow the decimal. So the one behind the 10 is actually per 100. So you can just write 3.10, but 2 decimal, 3.04, 3.16, and this is 60 seconds. 1 minute, this is 55 seconds. Add up together is 115 plus 0.11 second. Okay, remember this is the one. Okay, the last one I need to discuss will be concentration. But this one, very small chance of coming out because concentration, right, is what we call that very time consuming. But if you really come out, you have to do it fast. Okay, so the idea is this. To control the concentration, they'll ask you to pour the acid 45. Then you need to dilute the acid by adding 5 cm³ of the water. Okay. Then the next one is 30 matched with 15 water. The next one 50 and 50. 25, 25. Half. So how do you calculate the concentration? You see, we go learn the formula that M1V1 equals to M2V2. So if you move this thing here, M1V1 over M2 over V2 will equals to M2. So this is the formula. So my V1 is here, 45. So M1 is this one, 1 times 45 So my M1 1 divide by 50. So the total volume is 50. So I will get the first one is 0.9. Then this one is also 1, but the M1, V1 becomes 35. Then add water until 50, you get 0.7. Then this is got 25 acid, add water until 50, so you get 0.5 here. This one very important in calculation because we need to draw the graph. So guided experiment, then from here, you have to construct a table. Remember, this table is not given, so you will need to calculate out the concentration like what just how we did. Then after that, take the result, and this is the graph. So they want you to plot a graph between 1 over time against concentration. So I already plot this graph also for you. But for concentration, the graph is a straight line graph. It's a straight line graph, okay? And it touches 0 because at 0 concentration, of course, no reaction. No, don't have chemical inside, so no reaction will occur. So remember, you reach 0 and it's a linear graph. So remember, temperature is a curved graph in the new syllabus. Then after that, straight line graph is for concentration. Yeah, so this is the idea. Then after that, we back to here. Same, they'll ask you to get a reading. So the relationship is also higher. Relationship also higher. Then after that, they ask a reading for 0.6. So from the graph, you have to look at the graph, find 0.6 here, plot up, and get the reading 0.0166. From 0.0166 there, then you do the calculation to find out what is the time taken. You get 60.2. Same observation, manipulated to change to concentration. Hypothesis, everything same, just change to concentration also. Then for the operation definition is the same with the previous one, not much different. The reason is because the only difference is the temperature and the concentration difference. Here they ask you if they replace your sulfuric acid, what will happen? Of course, you'll be shorter time. Why? Because one is diprotic acid, one is monoprotic acid. So diprotic acid means H2SO4. You're able to produce 2H plus. Then HCl, you'll produce 1H plus. Okay, so this is the idea. So why you can see just now, 45 plus 5, 35 plus 15, 25 plus 25, the volume always 50. The reason is because if your magnesium is inside, right, if the water level is higher, harder to observe. If the water level is lower, will be easier to observe. So this will affect your result. So to be fair, all must be same height, so that the result taken will be similar. It's fair for everybody. Then they ask you, can sulfuric acid replace with hydrochloric acid replace sulfuric acid? Answer yes, because magnesium actually reacting with the H+. Whether H+ pair with Cl, pair with nitrate, pair with sulfuric, it also react with the H+. Okay, so good luck for Wednesday.